Inverse functions can be found by interchanging the domain with the range. So if this is our original relation, the inverse of it would just be this. So for the first one, the domain would be 2, 3, -4, and then 2 again. And the range would be 5, 7, 5, and 9. And the inverse of the red function would become this. And the domain is now 5, 7, 5, 9. And the range is, 2, 3, -4, and 2. And just to point out, neither of these are functions, right? We have an x value going to 5 and the same x value going to 9. So that wasn't even a function. And also its inverse, we have a 5 going to a 2 and a 5 going to a -4. So actually neither of these were functions, but that is the basics of how to find the inverse of a function. So let's get some notation out of the way. If you're talking about some function f of x, its inverse would be written as this. Okay, so anything to the negative first power is basically an inverse. So make sure you understand that this is the original function. And this one is the inverse of the original function. Now, of course, most of the time you see functions written like this. You don't usually see ordered pairs. But the idea is still the same. All we're going to do is rotate, or switch out rather, the x values and the y values, the domain and the range. And so I'm going to write it like this. So we have x equals f of -1, and that's just notation. So this f to the negative first power of x, that just says, right, that's just the inverse of this. And so this is little notation for you. And so you do want to solve for f of x here, or the inverse of f of x, by adding 5 to both sides. And so we have the inverse of our f function is simply x plus 5. So if we do the same idea over here with the g function, the red one, again, the first step will be to switch out the x and the y values, or the domain with the range. And we would have this. Again, just the notation is once you switch out your domain with the range, you're going to use the inverse notation. And then we're just going to solve for the g of x, or the inverse of g of x, by subtracting 4. So then we would have x minus 4 equals -1/4 of our new y value. And you can think of dividing by -4, but what's even better is to multiply by the reciprocal. So I'm just going to multiply both sides, or all terms rather, by -4. And so then we'd have our inverse of g of x equals 4x plus 16. So something interesting happens when you graph a function and its inverse. And I put on, this black line here is f of x equals x. It's just the 45-degree diagonal through the origin there. So when we graph this, look what happens, comparing these two functions that we have together. If we start down here at -5 and we go up one to the left one forever, it would look something like that. And if we graphed its inverse, what you should notice is that these are reflections across the y equals x line here, the f of x equals x. The original function and its inverse are reflections across y equals x. So here's the other example we used about to find the inverse of a function. And, this is just another way to show, to check your work kind of thing. So let's plot these two. So there's 4. And we're going to go down 1 over 4. And so if we found this correctly, we're going to have a reflection. I should have done that in blue, but let's do this one in blue. We're going to have a reflection over the f of x equals x line again. And what that's going to do is it should meet right on, these two lines should meet right on the f of x equals x. So my graph is a little too small to show the whole thing, but if our x value was 4, we plug that in. -4 times 4 is -16. -16 plus 16 is 0, so we would be right here. And then we can do our negative slope. So that would be up 4 over 1. I'm off my graph here, though. Well, we can do it this way. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And you see that these, in fact, would be reflections over the y equals x line. Now, like I said, I was unable to really start up here on the y-axis because I had to go to 16, and it's not there. But once I found this point, instead of going, full up 4, because then, I'm going really too steep. I'm going way up here over 1. Well, I guess it's still there. But I am able to count just these little lines also. That's fine to do. So, again, the point is that if two lines are inverses of each other, they would reflect over the y equals x line.